Good morning, class ninth. Let's begin with a new chapter of physics, chapter 8, motion. In everyday life, we see some objects at rest and others in motion. Birds fly, fish swim, blood flows through veins and arteries, and cars move. Atoms, molecules, planets, stars, and galaxies are all in motion. Let's begin with the introduction. We use the word rest very often. For example, when someone is doing nothing or someone is lying on the bed, we say that person is taking rest. This means that person is not moving. But scientifically, we can say that an object is at rest when the position of the object does not change with time with respect to its surroundings. Similarly, motion is defined as the change of position of an object with time with respect to its surroundings. The word motion simply means movement. When the object moves from one place to another place with respect to its surroundings, it is known as motion. Now, what do we mean by with respect to the surroundings? An object may appear to be moving for one person and stationary or at rest for some other. For example, the passengers moving in a moving bus appear to be moving by the person standing on the roadside. However, a passenger inside the bus sees his fellow passengers to be at rest as the position of the person does not change with time. Therefore, to describe the position of an object, we need to specify a reference point called the origin or reference frame or frame of reference. Most motions are complex. Some objects may move in a straight line, others may take a circular path. Some may rotate and a few others may vibrate. There may be situations involving a combination of these. In this chapter, we shall first learn to describe the motion of the objects along a straight line. The simplest type of motion is the motion along a straight line. We shall first learn to describe this by an example. Consider the motion of an object moving along a straight path. The object starts its journey from origin point O, which is treated as its reference point. Let A, B, and C represent the position of the object at different instants. At first, the object moves through C and B and reaches A. As you can see in the figure, from O to A, it covers a distance of 60 km. Now, after reaching A, it moves back along the same path and reaches C through B by covering how many kilometers? Yes, 35 kilometers. Now, the total path length covered by the object is equal to OA plus OC, which is equal to 60 kilometers from OA and 35 kilometers from OC, is equal to 95 kilometers. The actual path length which is covered by an object is called its distance. The SI unit of distance is meter. Displacement. Displacement is the shortest distance which is travelled by a body from its initial position to its final position. Its SI unit is also meters. Now, let's see what are the differences between distance and displacement. As we already know, distance is the total length of path covered by an object, whereas displacement is the shortest length of path covered by an object. Distance has only magnitude and no direction, whereas displacement has both magnitude as well as direction. Now, what is this magnitude? The numerical value of a physical quantity is called its magnitude. For example, 5 meters, 2 kgs, 6 kilometers, etc. These all are the numerical values of any physical quantity. This is known as its magnitude.